Well, Dr. Jabbour, thank you for being here. I appreciate you being part of the show today. This is so important, and it is the reason that I agreed to do this. Tell us what an fMRI is. Everybody's heard of MRI. Tell us what an fMRI is.
So with functional magnetic resonance imaging, we now have a mechanism to see the thinking brain, to analyze the brain not just as a shape, but to actually have a window into how the brain is thinking.
Okay, so in other words, we're able to see what the brain looks like when it's performing certain functions, when it's doing certain things. We have an image up now where this is one of the images, a 3D image that you guys generate in this Star Wars technology you have, where you're basically showing the circuitry of the brain, the wiring of the brain. Let's take a look at the first image and see what we have found here. Now, what we're looking here is at JJ's brain scan. We're talking here about basically you see that his brain is actually shrinking inside the cavity, correct?
Yeah, the analogy is if you imagine a grape, a nice plump, healthy grape. It's got a nice smooth, maybe a little fold here or there, but when it becomes a raisin, it shrinks and develops multiple folds. So really, when you abuse your brain over a long period of time, the brain, just like a grape, will shrink back and you'll see more space between the skull and the brain itself. The white represents fluid, the cerebrospinal fluid, that becomes a bigger space when the brain shrinks.
Okay, so we're talking about these spaces here.
The thing about JJ's brain is it's very prominent in the frontotemporal area, the very important area for executive function where you think and plan your life.
This is the most sophisticated part of the brain.
We have an indication that there's going to be some more abnormalities as we delve into the scan in more detail.
Okay, tell us what we're seeing here. We have JJ's brain on this side, a normal brain on the other side.
So if you think of the brain as a machine, this is a measure of the flow of blood to the brain. A normal brain in a right-handed person should have dominant activity on the left. Now, the red represents good function, more. Blue and black mean less. So between red and blue, you have orange and yellow, so there's this grade of activity. So you have good activity throughout the left brain in this normal person who's right-handed. You can see that in JJ, just immediately, that there's much less red activity. The engine is not working.
Let's take a look at this, which is the brain at rest.
When the patient's in that scanner and they're not thinking about anything, just letting their brain ruminate, you should only have, in the normal population, the green represents what the footprint of the default mode network would be in a normal population. In JJ, he has multiple default mode networks instead of just one. And each of those networks is hyper connected, which is an indication that he has disrupted brain networks. Mm-hmm. And this means that the computers in the brain, many different computers hooked to each other, the computers are just not talking to each other.
This indicates, because this yellow should be not visible, this should be smaller than what we have green, which means the default network is disrupted. His networking is not right. Let's go back to the image right before this. Here we see metabolically he is disrupted because he is not getting enough oxygen and other activity metabolically in the brain, particularly in the executive functions. And if we can go to the image right before, we can see that the brain is actually shrinking inside the cavity here.
Yes.
So the brain is shrinking, the metabolic activity in the brain is shut down, and the networking in the brain is disrupted.